All right, so now we're going to solve an equation involving an absolute value. Now that you've done these before, if you have something like the absolute value of x plus 2 equals 5, we know the argument, what's inside the absolute value. That could equal a positive 5 or a negative 5, because as soon as you take the absolute value, you're going to be back to positive 5. And then you just solve each equation, subtract 2 from both sides, and we get these answers, and you're done. So easy peasy lemon squeezy. What do we do over here? Well, essentially the same thing. I'm going to take what's inside the absolute value, x squared minus 3x, and we're going to set it equal to negative 4x plus 6, or the negative of negative 4x plus 6. Sorry, it's running into the pink there. Either one of those could work, because again, once we take the absolute value, we'd be back at negative 4x plus 6. Then we just solve each one of these quadratics. The first side, so you add 4x onto both sides, we get x, subtract 6. This guy factors into x plus 3, x minus 2. We get x equals negative 3 or positive 2. The second one, I got to distribute that negative on the right-hand side first. Then I'll subtract 4x from both sides and add 6. We get x minus 6, x minus 1. So x is equal to 6 or 1. So looks like I got 4 possible answers. And I say possible because some of them may be extraneous. Yes, we may have extraneous solutions here. So why is that? Let's go back and look at the pink problem first of all. If we look at the pink problem, we didn't have any potential problem here because we had a positive 5. On the left-hand side, the absolute value is automatically going to make things positive, and we're setting it equal to a positive number. Like, that's good. The problem with this equation is right there. What if one of these values of x makes that highlighted portion equal a negative number? There's no way this absolute value could equal a negative number and we'd have an extraneous solution. So you're going to have to check for extraneous solutions. So let's check. And if we check x equals negative 3, remember, always go back into the original equation, so I'm going to go back into that. I have the absolute value of negative 3 squared minus 3 times negative 3 equals negative 4 times negative 3 plus 6. I'm going to have the absolute value of 9 plus 9. Will that equal 12 plus 6? I should put my question marks. Does the absolute value of 18 equal 18? Why, yes. Yes, it does. So x equals negative 3 works. And we just keep doing this. Now we're going to check x equals 2. Absolute value of 2 squared minus 3 times 2 equals negative 4 times 2 plus 6. I have 4 minus 6 in the absolute value. Will that equal negative 8 plus 6? Will the absolute value of negative 2 equal negative 2? And no, because now I wind up with positive 2 equals negative 2, and we know that's not true. So x equals 2 is extraneous. Let's go on. Let's check. X equals 6. Isn't this fun? This is not fun, I agree. This is the kind of stuff in math that I don't enjoy. But it's got to be done. So we have the absolute value of 36 minus 18. Does that equal negative 24 plus 6? Does the absolute value of 18 equal negative 18? And no. Again, we're getting a positive equal and a negative. That's not true. Cross out 6. And then finally we'll check x equals 1. Absolute value of 1 squared minus 3 times 1 equals negative 4 times 1 plus 6. Is that true? Well, we get 1 minus 3 in the absolute values. Does that equal negative 4 plus 6? Will the absolute value of negative 2 equal 2? Why, yes. Yes, it does. So we have two answers. Our final answer is that x can equal negative 3 or positive 1. And voila, there's our answer.